In this lesson, we are going to learn about the dual nature of light. In classical physics, light is treated as a wave. Why? Because it undergoes interference, diffraction, polarization. All these are properties of waves. And since light undergoes interference, diffraction, and polarization, we treat light as a wave. In classical physics, light is an electromagnetic wave. We have got electric field oscillations, perpendicular to that magnetic field oscillations, and the light propagates perpendicular to these two oscillations. Say the electric field oscillations are along y-axis. The magnetic field oscillations are along z-axis. Light will travel along x-axis. All three are mutually perpendicular. That is why we say light is a transverse wave. In fact, polarization tells us that light is a transverse wave because polarization is a property of transverse wave. The first person who tried to understand the nature of light was the great Newton. He thought light is a particle and he gave the corpuscular theory of light. At the same time as Newton, there's one more scientist called Huygens. He thought that light is a wave. In fact, he thought light to be a longitudinal wave, but that is wrong. But he was the first person who thought that light is a wave. People were thinking whether light is a wave or particle. Newton had more reputation. He was a very big scientist. So people initially believed that light is a particle. But later, one very famous experiment was done by Thomas Young called Young's double slit experiment. This is an experiment on interference. Thomas Young showed that light undergoes interference, and interference is a property of waves. Therefore, it was established that light is a wave. Then experiments on diffraction and polarization established light to be a wave. So this was going perfectly well. Everyone was convinced light is a wave. Then a very important phenomenon called photoelectric effect was discovered by Hertz. He and his students studied this photoelectric effect in lot of detail, and their observations could not be explained by taking light as a wave. Einstein in 1905 took light as a particle to explain photoelectric effect, and for this he got the Nobel Prize in physics in 1921. Remember, Einstein got only one Nobel Prize, and that was for explaining photoelectric effect. Now we have a problem. We do experiments on interference, diffraction, polarization. We get convinced that light is a wave. We do experiments on photoelectric effect, Compton effect. We get convinced that light is a particle. Compton effect is one more experiment that establishes the particle nature of light. Now what is light? How can light be both a wave as well as a particle? Light behaves differently in different situations. When light propagates, it propagates as a wave. When light exchanges energy with material particles, it behaves like a particle. You may say how that is possible. How light can be a wave as well as a particle. The simplest way to understand is this. Now I look at you in the class, I'll say you are a good boy, good girl, very well disciplined. I see you outside doing some mischief, I'll say you are a bad boy or bad girl. So you are not good or bad. You have got a good nature and a bad nature. Same way, light has got a wave nature and a particle nature. In some situations, light behaves like a wave. In some other situation, light behaves like a particle. Now what about particles? Can they behave like waves? In fact, particles like electrons also have a particle nature and wave nature. In classical physics, you treat electrons as particles. Why? Because they have got mass, they have got charge, and they behave like particles in devices like television picture tubes. But there are other equipments like electron microscope, which actually use the wave nature of electrons. So particles like electrons also have a dual nature. Light has a dual nature, electrons have a dual nature. This wave-particle duality is a general property. Everything has got a particle nature and a wave nature. So in this lesson, we learnt about the dual nature of light. We also learned that particles like electrons also have dual nature.